Let's go to see the exercises for 8.1. Number 1, an experiment consists of drawing a card from a deck of cards. What is the probability to draw a black card? As you know, we have 26 cards out of 52, so the probability will be 26 over 52 or 1 over 2, 0.5. What is the probability of drawing a 6 of clubs or a 6 of diamonds? We have 1 6 of clubs and 1 6 of diamonds, total of 2. So the probability will be 2 over 52 or 1 over 26. If you want, you can write it as a decimal 2. Number 2. An experiment consists of dealing 4 cards from a deck of cards. Don't forget, on the previous example we have to pick up 1 card. In this case we have to choose 4 cards, so we have to work with combinations. So what is the probability to have 4 aces? In this case we have 4 aces and we want all of them, so it is a combination of 4 and 4. And then we have 52 cards to choose 4. So the denominator will be combinations of 52 and 4. As a result, in the first case the answer is 1, in the second case is 270,725. So the probability will be 1 over 270,725. Let's go to use the graphing calculator. For the numerator we can have math, then probability, number 3, 4, and this is 1, and then you can divide. It is a good plan to use a parenthesis. We have 52 cards and we choose 4. Probability, combinations, 4, close the parenthesis, and this is going to be your answer. Don't forget, this is how many zeros you have before the number. If you have E-6, that means the answer is 0.00000 and then the number. Next one. Same problem. What is the probability to have 3 aces and 1 king? It's combinations of 4 aces and 3, and then we have combination of 4 kings and 1. So it's combination 4 and 3 times combination 4 and 1, because we want 3 aces out of the 4 and 1 king out of the 4. So we have 16 ways over the same denominator, 270,725. And this is the answer. What is the probability to deal a hand with 1 ace and 3 kings? It is going to be exactly the same numerator. It's going to be combination of 4 and 1 times combination of 4 and 3, which is going to be 16. So the answer is going to be exactly the same. What is the probability to have a hand with no aces? No aces means that you have 48 cards left. Why 48? Because you have 52 minus the 4 aces, which is 48. So you want 4 cards that are not aces. So we have combinations of 48 and 4, which is 194,580 over combinations of 52 and 4. So the answer is going to be 0.72. That's about problem number 2, that you look for a probability. For problem number 3, we have a class of 26 students, 14 freshmen and 12 sophomores, and they have to select 3 students for a committee. This is similar to 7.4. You don't look for a probability because it doesn't say what is the probability. So you don't have a denominator. They ask you how many 3-person committees can be chosen from the class. So the first one, you have 26 students to choose 3. So it's combination of 26 and 3. 2600 committees. How many 3-person committees can be chosen from a class if the committee consists only of freshmen? How many freshmen we have? We have 14 freshmen. So it will be combination 14 and 3. So 364. And how many 3-person committees can be chosen if the committee consists of only sophomores? We have 12 sophomores, combination of 12 and 3, 220. And then how many 3-person committees can be chosen from the class if the committee consists of 2 freshmen and 1 sophomore? So we have combination of 14 and 2 because we have 14 freshmen and 2 of them are going to be in the committee, and then 12 and 1, 12 sophomores, and we want 1 sophomore in the committee. So it will be 91 times 12, which is 1092.